And at this point, I'd like to invite our 6 panelists to come up. So first is Simon Gautry from WSP, David Lang with the PGO, and you guys can take a seat up here. Maurice Dussault with the University of Waterloo, Dr. Dave Rudolph with the University of Waterloo, Dr. Randy Stadler, University of Waterloo, and Dr. Emmanuel Arnaud from the University of Guelph. Okay, so we think we have a really engaging topic to discuss today, and given the OGS's extrication from the event, we have a longer time frame than normal. So Don Ford initially proposed this title for the panel session, and on the organizing committee, as we discussed it, we got kind of excited about it. We think it's a timely topic. And I think your panelists here will give you some insights into why we think it's timely, why we think it's an interesting topic to discuss, and hopefully at the end of the presentations. So each panelist is going to provide a perspective on this topic from their point of view and different angles. We've got, PGO, we've got industry, and we've got universities. And then we'll open it up to questions at the end of everything. So to start off, I'm going to ask Dr. Dave Rudolph to come up. He's going to be our first presenter along with Randy Stadler. And your slides you can see down below you there. If you need.
Can you? There. Oh, you have to do it here. Okay, well.
Page down on the computer.
Great, thanks. Thanks, Steve. And so on behalf of the panel, to Don and Steve, thanks so much for conceiving this and coordinating it and managing this herd of cats here to get us here today. And thanks for everyone for joining us. What a wonderful turnout. We're glad to have you here. So the topic we're going to speak to, every one of us on this panel is influenced by this in their own way and have been struggling with it for the last while, from academics to folks looking for people to hire. And in the thought of transparency, it's also a bit of a selfish panel for us because this would never be a better opportunity for us to have a group like this to get input from, to get insight from, and to sort of overview what we're thinking of and what the trends are showing. So there's really quite an evolution in geoscience education going on. I think we'll try to get a lot of that out to you, but we're looking for ways to get input from you. So to that point, I'm going to ask our super tech savvy colleague and panelist, Randy Stadler, to show us a technique we're going to use this afternoon to have direct interaction from the audience. So even I figured out how to do it, so everyone should be able to do it. It's an interactive opportunity, and Randy's going to show us how to do that. There we go. We'll get started with that.
Okay, so this is the point in the meeting where you're allowed to pull out your phones. Get out your phones or your laptops if you want. You can scan the QR code. If the QR code doesn't work, just go ahead and type in vivox.app on a browser, and then enter the session ID, and you'll find your way there. And we'll go ahead and ask you guys for some feedback throughout the talks this afternoon at different points in time. And so we'll get a little bit of information from everybody here and everybody online as well, and try to get as broad of a view of what everybody thinks as we can. So hopefully that kind of helps juice the conversation a little bit. Okay, and if for whatever reason you kind of lose track of this, as we're asking questions throughout the presentations, the QR code won't show up, but the link will, vivox.app, and then the session ID will as well. So. Okay, and just to try this out, let's see if this can work. If you look on your phone, you should start seeing, it looks like people are starting to answer this, so just to get an idea of where people are coming from here. All right, so we've got about 166 people have managed to answer so far. I'll give it another minute or so here. as people are coming online. Most people here are looking like they're coming from industry, followed by government, and academia behind that, and then a few people in public and NGO space as well. Yeah, right. Other. I thought I had an other, but it disappeared on me. So, yeah. It's on the poll. Okay, so we'll be able to see those results on later. Yeah. Okay. Just closing this off. Okay, 9% are other. We've got about 42% from industry, 32% from government, 2% from NGO, 1 in the public space, and then almost 13% academic. Excellent. Okay, one more question here, and this is going to kind of start the conversation off, and then I'll hand it over to Dave. Are industry and government having a hard time identifying an appropriate new geoscience employees? Okay, so as people are filling this in, so far it looks like yes is winning, followed by I don't know. So, which is fair enough if you're not in the space where you're potentially trying to hire people. Okay, about one more minute here, and then we'll move on. All right, this is great. So early on, these are going to be kind of yes/no questions. A little bit later, we're going to ask for some longer responses from you guys. So we'll try to give you some time to type those in as well. Okay. All right, so there's our kind of final poll results here. 45% or so are having a hard time, 43% don't know, and then 12% you guys are in good shape. So, okay, with that background, I'm going to hand it over to Dave and let him kind of work through some statistics for you guys.
Okay, so I'm hoping that that's working. What we thought we'd do at the very beginning is just to provide a little context from sort of a international, national, and then local point of view on where students are applying, what sort of the rate of applications are. And this first slide was put together by an Australian group just a few years ago, and they took data from the United States looking at graduating students in geosciences and geoscience in general, including geological engineering and a few other areas like that. And they also looked at Canada, the UK, Australia, of course, their own, and Italy, and in order to kind of sort of look broadly across the globe as to what's going on for trends. So this is really interesting. It takes us back to 1980, I think it starts. The right-hand side is graduating students in US, and the other side are all the other, this is first-year enrollment, so students coming into the program. So the first thing you see is that the countries are tracking relatively similarly. So the situation is a global trend. And the second thing you see is this relatively uniform cycle. So I think we could all sit and try to figure out exactly why it's high and why it's low under this 15 to 20-year cycle, which is interesting, probably mostly economic in terms of how resources are being developed, what the jobs are looking like, and what the students perceive as being a job in the future. So from a global point of view, I think that's what we can see from this. You can see we're on the down end of it right now. So we're at sort of a low position in terms of total number of students entering the program or graduating from the program. And that's sort of in an international scale. So if we look at the Canadian scale, and this data comes from an interesting group called this is a great acronym here, the Canadian Council of Chairs of Departments of Earth Sciences. And we're going to have a quiz on that a little later to see who can remember that amazing acronym. Anyway, what that is a collection of folks across Canada who are the department chairs in the geoscience centers. At many of the universities, there's quite a few, get together once a year and worry about this data. So again, you see that sort of cyclical 15 to 20-year cycle. And this was a little bit more recent data, so you can see we're right at the moment, we may be on the tick back up of that cycle. Who knows what the next 4 years will bring for us, understanding so many things are changing politically. But you can see that that trend is starting to move up. Also on that plot, a little bit harder to see, and if you just focus on the ones that, the little symbols that are colored in, it's a little bit easier to see. What you see is that the trend in PhD students has progressively gone up gently. The trend in master's students over the last approximately 10 years has gone down. So that's a significant trend in lots of ways and been seen sort of internationally. What does that mean in terms of students coming into the workforce? So this looks at the graduating students with a BSc degree in all areas of geoscience that we look at, again, including geological engineering, and also for our graduate students. So again, we see this decline. So there's been a decline in BSc students across Canada by about 40% in the last 8 or 9 years. That's a lot. And in the PhD program, about the same. In the master's program, something like a 25% decrease. So when we first asked that question, are you having a hard time finding people? We get calls all the time looking for people. So I think the jobs are there, and we can probably produce more students. So we're at a bit of a low now, arguably, hopefully, on our way up. So that's from a Canadian perspective. If we get a little local, closer to home, so this is the data from our department, and this thankfully came from John's here somewhere. John, put your hand up. There he is way in the corner with his geological models. We're looking at the data from the Department of Earth Environmental Sciences, and over a chunk of that time I was the department chair, so as administrator I was looking at this data all the time. So you've all heard through the news that academic institutions are struggling financially. You hear it across the board. So to see these types of trends in student enrollments going down is a big concern, especially for geoscience programs, because we're relatively small compared to physics and biology and chemistry. So it's a concern. It's something we're looking at here. Trends you see in this one shows that the conventional or classical geology has probably come down the most relative to, in our case, geophysics and hydrogeology. Over the last 5 years, relatively constant, but you can see that we're down significantly from what we were back in let's say, 2014 or so. And most of you that know our department know us as being a producer of MSc students. That was really a core of our operation. So let's take a look at how our graduate students have been doing as well. But before I do that, one of the trends across Canada, and as I found out across all of North America, was the introduction of an environmental science stream. So this is running parallel to our classical programs in earth sciences or geosciences, and it's more of a general program. And we have 2 streams. One's called a water stream, the other one's a geoscience stream. And as you can see there, that's the blue trend. You can see how significantly that has increased compared to some of our conventional let's say, classical geoscience programs. So an important thing to keep in mind, the question is that influencing how many are going into the classical program because we have this alternative stream? When we now look at our graduate students here, this is sort of a trend in what we've seen in MSc students and PhD students, again, fairly constant in terms of the PhD students, but a progressive decrease in our master's program. So this is something that's being seen. Other examples are the University of Davis, California. We're working with them. University of Arizona. Those of you that know Ty Foray and have been harassed by Ty to get information to him. Arizona's super concerned about it. Their master's program is essentially done. They just don't have students coming into it. So a concern is, why are we not getting students moving into the MSc program? So just as we transition into the next presentation here, one of the things we're thinking of in our department particularly is trying to come up with some innovation on how to attract students into the MSc program. What is it that would be helpful? So I'm going to pass it on to Randy now, and he's going to give us an idea of what a new area that we're thinking of way of training and delivering MSc programs that hopefully will be attractive to a broader, let's say, group of people professionals that would want to move into this program. Okay, so I'll pass it on to Randy. Thanks.
Okay, thanks, Dave. So just a little bit of background for you guys that don't know me. I did get my graduate degrees here at the University of Waterloo. Then I moved to the University of Kansas for about 10 years or so, and we struggled with a lot of these same types of issues. Low enrollment, like Dave said, it's this kind of North American sort of an issue. Then I moved back here in 2020, and I've been working on some of these issues here since then, and kind of as well, I've got another hat that I'm wearing. I serve on the executive board with Jim Roy, who was just up here a little bit ago, of IAH, and so I'll be talking a little bit from that angle as well. So the first question that I've got for you guys here through this part, and this will be something for you to kind of work through a little bit longer. Why do you guys think university enrollments have been declining over time? So we've got some space for you to fill that out. And if you've lost the connection to the app, you can just type in. It's right up there at the top of the screen. This will take a little bit of time for people to fill in. It should start popping up. And if it doesn't,
Are there any prizes for the funniest answer?
fastest answer.
First one up gets a prize.
It's very quiet. It's like a test. Not yet. I'll have to hit the next button. When I close the poll, it'll pop. Still coming in here. We'll give it another minute or two for you guys to kind of wrap things up here. Okay, last 10 seconds. Get your answers in. Okay. And let's see here. It's not populating our results here, but we'll kind of come back to that here in a little bit. Part of the point of this, I think, is that we don't necessarily know all of the reasons, and so we're trying to start collecting some of the information that we need. One of the groups that's doing this is where I put on my IH hat. IH is currently working on a survey of its membership, trying to identify trends such as where people are, what sorts of things does the hydrogeology community think are important. So there's another survey here. This one's pretty long. It's about, probably will take you 20 or 30 minutes, but it's relatively comprehensive. It's geared towards IH members. If you haven't filled it out yet, We've got about 13% of the people who have responded already, which is fantastic. We'd like to get that up to about 20 or 30%. So please try to take the time to fill this out. If you're not a member of IH and you're sitting in this room, why not? It's a great organization. Do try to take a look into that. But in general, what we're trying to find out is, why are geoscientists important? Probably communication is a part of this. We need to get the word out to the general public. But we also need to know what skills do geoscientists need? As Dave helped point out earlier, is there a need for more geoscientists, or are we just kind of talking amongst ourselves? What can we expect geoscientists to do to fill knowledge gaps in the future? All of those kinds of things. One of the things that we've found very often are that geoscientists find their way into geosciences. They don't come into university expecting to get a geoscience degree. So how many of you guys have, in this room, for instance, started off in a different program, took Geology 101, discovered you really loved it, and stuck with the program? So for the people sitting up here on stage, it looks like around 40% of the people did switch into geosciences from another program. So, yeah. Okay, so the next question, and probably we won't get the results popping up on the screen like I'd hoped, but go ahead and take a minute or two. What strategies do you think might help support boosting enrollment in geosciences? It could be at the undergraduate level, it could be at the graduate level, anywhere kind of in between. Oh, good. Now we've got some answers coming up. Excellent.
Can you scroll back through?
Yeah, and it'll compile them on the screen. These are great responses, everybody. Excellent. Okay, let's go for about one more minute here. Okay. Looks like we're slowing down a little bit. 10 more seconds. Okay, excellent. So here's kind of a little bit of a selection here. We've got a whole bunch of different ones in here. A lot of the ones that I saw coming through were better outreach to high schools. I saw scholarships, tuition coming through, joint programs are up here, industry collaboration. These are all great, introducing elementary students in here. So a lot of outreach, right? All of those kinds of things. So here's some strategies that I've been working with here at Waterloo and at the University of Kansas, and we're trying to get them here as well. So what we're doing at the University of Waterloo, we're trying to get our most engaging and best instructors into those first-year programs. Trying to get people really excited about the classes, because we know that people are transferring into our program from other programs. Trying to get these really broad appeal lower level classes, kind of moving beyond just Geology 101. We do get a lot of people from that kind of class, but also, you know, other classes that might be of interest to people. You know, if we get a lot of students coming into our medical geology class that, you know, they might be working on a med school degree or something like that, and then they say, oh, medical geology, and they take that class. So trying to get a little bit more broad appeal classes out there. I'm trying to get students out into the field early. A lot of the geoscientists I know really like to go outside, and so this kind of gets people excited about going outside. Trying to remove barriers to access for non-traditional students. So this kind of goes for both graduate and undergraduate levels. And I'll talk a little bit more about that in a minute. Outreach and engagement is a big piece. I just heard our department is going to be starting a high school camp for high school students. So they're going to come for a week in August and actually kind of work with people in our department. So those kinds of things. Engagement is a big one. Industry connections, I saw that scroll through earlier as well. Really important. Scholarships, we've got to find a way to get the best students here excited about earth sciences, kind of pull them away from environmental studies and that kind of thing. At the graduate level, we're trying to work on flexible graduate programs. I'll talk about that a little bit more in a minute. Certificate programs, these are a big thing, so maybe we're not necessarily just getting people coming in for a full degree, but maybe they need to upskill a little bit, and we've got to make those types of things a little bit more accessible. Industry connections, if we're not producing the students that industry needs, then we're not doing a very good job. So we've got to make sure that it's kind of a two-way street where we're working with industry and industry is working with us to make sure things are going well. So what I'm currently working on the most, this is taking a lot of my time, is putting a proposal together. We're developing a new master's program here at the University of Waterloo. This is going to be predominantly online. There will be a short residential period, probably on either end of the degree. Furiously trying to meet deadlines so that we can get this launched in fall of 2026, get through the approvals process. The initial, we're going to have multiple streams, specializations within this. The initial one is going to be hydrogeology, because that's what Waterloo does really well and has done for a really long time. Let's see here. Basically, our audience is going to be people who are working. So because this is online, this is going to be relatively flexible. You could be in Toronto, you could be in England, you could be in India, you could be here in Waterloo, taking these classes kind of mostly on your own schedule, working your way through. So definitely people who are working, trying to upgrade their skills. Also current students here, undergraduate students, different institutions. Basically trying to go after those people who are really interested in getting more skills, but maybe not going through the whole thesis process. So this is kind of like Dave said, we're just trying to gratuitously gather information here. So a real quick question, do you think your group would be interested in supporting this type of program? This could be support where you're hiring students from the program, or maybe we are going to develop an industry advisory board for this program so that we're making sure that the students are relevant to industry. So perhaps serving on that board. Okay, excellent. Okay. I'm just going to wrap that one up relatively quickly. So thank you for your support. I appreciate it. Hopefully, if you do have interest in helping us out as a member of an industrial advisory board or something, please see me and we can kind of chat a little bit more later. Just To kind of wrap things up, though, a lot of what I saw out there was engagement, outreach, and those kinds of things. I think we all have a role in doing this. This is kind of something that I've learned over the last year working with IH. We've got this group that's really trying to advocate more for groundwater within the federal government and across Canada. And, I think it started because a lot of us were standing there thinking, somebody should be doing this, somebody should be doing this. And finally, somebody was like, that should be us. And if we're not doing it, then who's going to do it? So I think we all kind of have a role to play. We don't have to necessarily be the ones who are, writing letters to the editor or something like that, but, every little bit can help. So that's kind of where I think I'll wrap up my little advocacy piece, and I'll turn it over to David Lang, who will not be doing any advocating necessarily. So.
Oh, explains why my VCR still flashes 12. Okay, good afternoon, everyone. My name is David Lang. I'm a volunteer with PGO. I sat on a PGO council for a number of years, and I'd like to highlight that there are 3 other PGO volunteers here. Zen Kaiser, who's the VP of PGO currently, Simon Gautry, and Tammy Middleton. So there are a number of volunteers here. If you have any questions, please feel free to corner any one of us if you have any questions. I am going to be wearing 2 hats today. I come from a mining and exploration background, but for the purposes of today's talk, I will be speaking on behalf of PGO, the provincial regulator. So in my natural environment, I wear PPE, and in my other life, I do a lot of endurance cycling as a pastime. Neither here nor there, but a little bit of background on me. So normally, PGO is the regulatory body that oversees professional geoscientists in the province of Ontario. There are a number of regulated professions in Ontario that we already know about: engineering, law, accounting, and so forth. And the primary reason for having a regulator, as is PGO's mandate, is to protect the public by ensuring those that are practicing professional geoscientists have the commensurate experience, education, and the ethics in which to do so. PGO is a relatively new SRO, regulatory organization, self-regulating body. PGO was created in 2000, subsequent to the Bre-X scandal, which, for those of you who have not seen the movie Gold with Matthew McConaughey, which is very loosely based on the incident, Bre-X was a $6 billion fraud that nearly destroyed the Canadian capital markets. It had a ripple effect through the broader financial markets and took its toll on the Canadian economy, given how important mining and resources are to the Canadian economy and the jobs as well. So now that professional geoscience is a regulated profession in the province of Ontario, I'm here to talk a little bit about what PGO does, its function, and how we as a regulatory body, royal we, what our responsibilities are and how we interact with young geoscientists at the undergraduate level as they come into the fold itself. So a snapshot of PGO's various classifications. As you can see on the pie chart behind me, the vast majority are in the mining and exploration industry. The numbers are a bit small, but all combined, there are about 3,500 registrants or members in the province of Ontario. Vast majority are in the mining sector, followed by environmental science, geophysics, and then the undetermined and no data. And on the far right, you can see the breakdown between GIT, a rather unfortunate moniker, which is for geoscientists in training, GIT as opposed to GIT, students, full practicing members, and then non-practicing. So this gives a snapshot of the number of registrants that are in the province of Ontario. The upcoming slides that you will see have been included to show how we have converted the number of students that are going from undergraduate, they become a GIT or geoscientist in training, and then progress to the full practicing membership. So on the far left, starting in 2008, this is the number of GITs, or geoscientists in training. To the far right, which is end of 2024, from 65 in 2008 to 717 in 2024. And this is in large part of our responsibility as an organization to go to universities like Waterloo here. We were here in November of last year to talk to students and provide them guidance on the curriculum that they're taking, the courses that they have to fulfill in order to meet the knowledge requirements. So there's an outreach program that a regulatory body like PGO is very active in. Every geoscience department in the province gets a visit from PGO at least once a year to connect with students, to ensure that not only what courses they're taking are in line with knowledge requirements, but also to provide feedback about upcoming courses and so forth. And towards the end of the presentation, I've taken some screenshots from some of the outreach programs that PGO offers, along with a course that was rolled out about 5 years ago from Geoscience Canada, which is specifically aimed at undergraduates and newly minted GITs and PGOs about their role as being a qualified person, regardless of what stream you happen to be in, oil and gas, environmental, or mining. And that has been met with universal acclaim as being wow, we didn't know it was that diverse as far as career options and what we have. So there's a lot to be offered. What we're able to do is to interact with students and say, this is what's available, come and talk to us. Full practicing PGOs by the numbers. 2008, the numbers are a bit small, but 1,429. On the far right, 2,488. So nearly a doubling in that span. So the message to take from these slides is that we're seeing a steady translation from student to GIT to PGO, and we're seeing an increase in the number of people that are getting their designation. Remember, practicing geoscience in Ontario requires that you have a license, as the same with any other regulated profession. And the total number of registrants, so this would be students, GITs, and various designations of PGO Limited, from 1,533 in 2008 all the way up to the end of 2024 at 3,648. So the progression of slides is to show how the population, which is largely bimodal, under 30, over 60-ish, we are seeing that as people are leaving the ranks, whether through retirement, passing away, that we are seeing a cohort coming into to fill that void. So those are some of the numbers reflective of the registrants. The next two slides highlight what it is that PGO does on a very active basis. And before I get into this, I should say that PGO is largely driven by volunteers. The people that I've mentioned that are here, we all lead professional lives. We are all also volunteers, long-standing volunteers with PGO. PGO is always looking for volunteers for committee work, for council. So if you happen to have any questions, once the session has, or whichever, if you'd like to speak, please feel free to speak to any one of us, and we'd be happy to talk a little bit further about volunteer opportunities. So the Student Outreach Program, this is a screen capture from the presentation that was actually given here at Waterloo in November of last year. And the purpose behind this is it usually brings in the registrar and one other person from the region to talk about professional registration, why it's required, aligning courses with knowledge requirements, and it also gives a room of students chance to ask questions to people who are either in their field or perhaps in a completely different area of professional practice. And with this outreach program, it's to highlight, yes, you are on a journey towards getting your degree, your GIT, and then your full designation, but it's the career path, it's the variety of career paths that usually blows people away. although you're getting a degree in geoscience, there's a variety of different industries that you can get into. Capital markets, research, law. And that's what this is designed to highlight, is that yes, you are getting a degree, but the number of options that you can go into subsequent to that is limitless. So this is some screen cap of the program. The idea behind just to familiarize students with what PGO does as a regulator. This was rolled out as a full-day short course for students, newly minted GITs and PGOs, and it's a full day. I've given this course a number of times. It's securities law. It's capital markets. It's stuff that typically would be on par with watching paint dry, but it is informative. And this has also garnered, where can we get more of this? This has been developed by Geoscientists Canada, and all of the provincial and territorial associations have had their input into this. It's an excellent resource, and it's typically offered at least once or twice a year, either by PGO or other provincial associations. If there's any interest in finding out more about this, please speak to us after this. And that's my 10 minutes plus or minus. So thank you very much.
Okay, page, up, down, down, there. I'd like to tell you that the oil and gas industry in Canada is not dead. It's not dying. It's evolving, and it's changing. But it's really in the headlines these days. I mean, pipelines. I mean, even Premier Legault of Quebec said a couple of days ago that, well, given social acceptance, we would be willing to reconsider the possibility of Energy East going across Quebec. Wow. That's a big shift, considering that in 2022, Quebec prohibited further drilling in Quebec. And that prohibition, by the way, is still active. But a lot of their cars and a lot of their homes are fueled with fossil fuels. Now, as the oil industry changes, the ratio of petroleum and natural gas being used for fossil fuels is going to drop and drop and drop. Other things will take place. So let's look at a few of them. So I started out my working life as a roughneck on the drilling rigs. So I used to work on something like that for a year as a roughneck, and a year and a half is what we call a mudman, right? And my record low temperature in my life is up in northwest corner of Alberta one night on the midnight shift when it hit minus 63 degrees Fahrenheit, which is minus 51 or something, 52 Celsius, okay? Whether it's Fahrenheit or Celsius, it's still cold. Yeah. Yeah, so I spent a year doing that. And then I spent a year and a half going around from rig to rig managing the drilling fluids. And then I met my wife, and I had to go back to university then. That was part of the conditions of a relationship. Yeah. So that's what it's like on a drilling rig in the foothills in Alberta in the winter. So I'd like to give you some context here as to why the oil and gas industry is actually so important to our graduates in the geosciences and geological engineering, even here in Ontario. When I was the chair of the geological engineering program back in the previous millennium, yes, we had some years where 60 to 70% of our students were going to Alberta, the co-op students in geological engineering. I mean, Syncrude was just absorbing these students, you know, in the 1990s, you know, when things were hot. Now, that cycle that Dave talked about a bit, I don't know if it tracks, but I've been through about 4 cycles in my career in the oil industry, which started in 1964, right? So cycles up and cycles down, and maybe that also affects our geoscience students' enrollments quite a bit too. So one of the reasons that, some of the reasons why it's an important hire of students and a provisioner of excellent careers is Canada is the world's fourth largest petroleum producer. Okay? We're the fifth largest natural gas producer. We could be the second largest natural gas producer if we had chosen to actually develop natural gas exports when these things started to develop about 16, 17 years ago. If you include exploration, drilling, production, refining, and marketing, the oil and gas industry in Canada is the largest industrial sector by a factor of 2.5. The next largest is banking. Yeah, it's huge, okay? And it's not just the Alberta economy, it's the economy of all of Canada that is involved. For example, there are communities in New Brunswick where the major source of income is salaries in Alberta. And there used to be, for example, out of Western Newfoundland, direct flights from the local airport in Deer Lake, in Western Newfoundland, to Edmonton. Direct flights, because people going in and out of a 3-week shift, right? So the benefits are spread across Canada quite substantially. It's the largest export sector by far. You know, you might think that just because we're the world's largest producer of lentils, yes, we are, by the way, the largest exporter of lentils, rather, you might think, wow, that doesn't even rank in the top 4 or 5. Canola oil, too, but that's a different kind of oil. Not only that, but Canadians work in the oil and gas sector throughout the world. If you want to go and visit Kazakhstan, go and become a geoscientist in the oil and gas industry. Mid-sized and small Canadian companies are active throughout the world. Recently, somebody decided to threaten another country with tariffs, and this country, Colombia, decided that they'd kind of give in. Well, a big sector of the Colombian oil industry is actually being developed by companies like Nexen and other small and mid-sized Canadian companies, well populated with geoscientists, some from Waterloo undoubtedly, and geological engineers. Very active internationally. And my Uncle Frank passed away about 6, 7 years ago. He was very senior in the drilling industry. He was called what you call a field superintendent for Jennings Drilling. And he got hired by the government of Iran back before the Islamic Revolution. He got hired by the government of Iran, and for 3 years he worked out of Tehran, going around collecting all the information, and once a week collating this and presenting it to the government. And he was recruited out of Canada. And when he was recruited, he says, "Why the hell did you hire me?" You know, he doesn't have a degree. He's only got grade 11. He says, they said, "Well, you know a lot about the petroleum industry. You speak English and French. And you're not American, you're not German, you're not French, you're not Italian, and you're not English." That was the reason he was given, right? The Canadians still carry that history proudly. You know, we do belong to the Western Alliance, but we are not dogmatically nor ideologically nationalistic like my next button here. So now I'm going to give you a little academic lecture here. Energy density. So on the upper axis here is energy density in megajoules per liter. All right? And on the bottom axis is the energy density in megajoules per kilogram. And you're going to see why oil and gas, well, oil, petroleum in particular, has been so important in our industrial revolution, right? Because they have a great energy density. There's diesel and gasoline for you. They've got a great energy density by mass, but they've also got a great energy density by volume. So you can fill your tank, and it doesn't have to be a huge tank or under great pressure. You can fill your tank and go 600, 700 kilometers. So let's look at some alternate fuels just for fun. So look at there's methane. And if you look at the bottom, methane gas, wonderful energy density by mass, but a really crappy energy density by volume. So the only way you can use methane in a vehicle is to compress it, compress natural gas vehicles, which never have caught on. Airways Transit, of course, you know, going to and from the airport for many, many years, I presume they still do have CNG vehicles. But it's never caught on for the consumer, and not quite sure why. Even liquefied natural gas, which we will soon be shipping out of the West Coast to points east, like Korea and Japan, liquefied natural gas is only about 60% of the volumetric density of diesel and gasoline. And you say, well, look, let's use alcohol. Well, look at alcohol. It's much worse, and methanol is even worse. Methanol is like 1/3 of the energy density per liter and 1/3 per mass. So you have to have 3 times the size of tank to give you the same mileage. Okay? And you might say, well, what about batteries? Batteries have a remarkably low energy density by mass and by volume. They don't rank well at all because the batteries are huge volume, very, very heavy. Your average battery car is, what, 60% heavier than your average gasoline vehicle, if I'm not mistaken? Something like that. So that's why. That's why we use gasoline and diesel as fuels, natural gas, of course, as a home fuel. But that will change. Nevertheless, oh yes, I included hydrogen here just to show you that hydrogen is great, but where are you going to store it? Storage of hydrogen is incredibly challenging because its energy density is 3 times higher, or 2.5 times higher than gasoline, but you got to store it in such huge volumes that it's verges on impractical. Even liquefied hydrogen has only 1/4 the energy density per liter of gasoline or diesel fuel. Nevertheless, remember that hydrocarbons are the reason, starting with the Industrial Revolution in the 1770s, 1780s, and starting in Britain with coal. When Britain learned how to mine and burn coal, the Industrial Revolution started. Your prosperity and mine are built on the use of fossil fuels, yet there are major issues with fossil fuels, and we can, on the horizon, see the day when fossil fuels no longer are used for fuels. Hydrocarbons are going to be used for other products. But just a moment about batteries, because we're all talking about critical minerals, and you know, when somebody stands up and says, we don't need Canada's minerals, we don't need Canada's oil, we don't need Canada's water, you can be damn sure they do. All right? You can be damn sure that those words were carefully thought out, because those words are actually diametrically opposite to what most people, most rational people would say. So, yeah, anyway. Battery energy storage systems are going to play a vital role in the future, for sure. And that involves us as geoscientists and geological engineers in mining and all aspects of the value chain, from right away the exploration and the mining, all the way to the recycling. And the recycling, I assure you, is going to cause huge problems for the groundwater contamination. Look, a battery is a box containing chemical soup, all right? That's the truth. But anyway, we're going to be leading in that area, but look at the bottom bullet. We're going to be helping replace hydrocarbons as fuels, replacing old problems, of course, with new problems. So eliminating hydrocarbons as fuels is a long-haul issue. It's generational or multi-generational, but it is happening. But that does not mean the end of hydrocarbons. We currently use about 20% of the crude oil produced for purposes that are not fuels, or maybe it's even higher than 20%. Just a few examples. Anybody here who is wearing any clothing that is made with an artificial fiber is wearing crude oil in another fashion. Every time a farmer in Canada uses ammonia in their field, they are using a hydrocarbon, methane, that was converted into ammonia by a well-known chemical process. Asphalt roads. Alberta, Western Canada crude, in Alberta and Saskatchewan, the heavy crudes, are the world's best crude oils for asphalt roads. It's the highest quality asphalt in the world, which is why it is widely appreciated in the United States as well. American roads are built with Canadian asphalt, in large part. Lubricants, etc. So we're going to be wanting to use those valuable molecules for generations and generations and generations, because making them artificially costs a huge amount of energy. So the oil industry is changing. But even as it's changing, there is still a large demand, because the oil consumption in the world right now is roughly stable at about 102 million barrels a day, of which about 5.7 of that is Canadian, right? And everybody predicts it's going to decline soon, maybe in the next few years, but it will decline. Maybe not at the rate that environmentalists would like, but probably faster than the oil industry would like, okay? So this involves subsurface engineering, and our graduates are basically subsurface applied geoscientists and engineers. That's really what it's all about for the oil and gas industry. The little cartoon diagram that you see here is just a reminder that we do careful three-dimensional seismic work to try to deconvolve the structural geology beneath our feet so that we can use that information to search for oil and gas. And seismics has progressed so astoundingly in my lifetime that at the beginning of my career in the oil industry, I did my PhD on oil sands. In the beginning of my career, you know, there was like one discovery for every 10 wells drilled. Nowadays, offshore, it's like you drill. The seismics is so good now that it's hard to drill a dry hole with good seismic analysis. It's really astounding. By the way, a dry hole offshore costs about $100 million, so there's an incentive to not have too many dry holes. These are just some of the disciplines that I managed to fit into one slide for the oil and gas industry who hire our graduates from all geoscience schools and all geological engineering programs in Canada. And they don't necessarily go to Alberta. They may go to Newfoundland. They may go to Saskatchewan. They may go international. Exploration geophysics, structural geology, and lithostratigraphic analysis, drill site geology, well completions, planning geology, geophysical log interpretations, reservoir engineering, reservoir geology, reservoir management, and then after that there's the environmental management, because you can't have a big industry like the oil and gas industry without some spills and without some accidents and without some concerns. Some people work on leaky wells. We have leaky wells here in Ontario from legacy oil and gas industry. So here's an image of a geoscientist at work, and the geoscientists on the drilling rig basically tells people when to stop drilling and take core, and what they should be doing. And the drilling engineer works very closely with the drilling geologist. And if you want to go and spend weeks up in the far north or maybe offshore drilling, there's always a good demand for site geologists. I'm sure that their partners are less enthusiastic about their husbands or wives spending days and weeks out in the boonies, but it's the way it is. And then, of course, there's the oil and gas environmental geoscience and geoengineering aspects. So we all have these environmental problems to cope with. Trust me, we will have similar environmental problems to cope with in terms of mining critical minerals, making batteries, and then recycling batteries. We're going to have spills. It is not going to be paradise yet. So I put this image of a leaking well here in southwestern Ontario on the screen just for you, Christine, to have a look at, right? And these people that handle these problems are hydrogeologists, geochemists, geological engineers, from Waterloo, from Toronto, from Queens, from Alberta, from BC, all across Canada. By the way, as an Albertan, I should mention that I believe that APEGA, the Alberta Professional Engineers, Geologists and Geophysicists Association, now renamed Alberta Professional Engineers and Geoscientists, I believe that APEGA was the first of the professional organizations to actually give a PGEO. Is that correct? I think that's the case. Yeah, I think so, yeah. So since that time, interestingly enough, professional engineering societies like our PEO here in Ontario did not agree to be the kind of the umbrella organization with PGEOs. PGEOs are separate in BC, in Ontario, and in most other provinces. Whereas in Alberta, the PGEOs are with the PEngs, and PGeophys as well. Geophysicists in Alberta have a professional organization. So I just want to put in a plug for some research that I'm doing, and that's subsurface storage. The nice thing about subsurface storage of energy is that it can be very large scale. So we're looking at natural gas, we're looking at hydrogen stored in salt caverns at a national scale. And when I mean national scale, I mean enough to supply energy for weeks, if not months. And that would probably be in salt caverns. Now, for those of you that are following what's happening in Eastern Europe right now, you probably realize that any surface facility is no longer secure from sabotage, attack, or vandalism. And if you're going to be storing your energy in the subsurface, in salt caverns or in porous media, or in old abandoned mines for that matter, what better way to counter the possibility of these issues? Pumped hydro, the Meaford program is going on, compressed air, etc. So what is happening is that the oil industry is not dying, it's moving into other things. It's moving into geothermal, it's moving into subsurface storage of everything, deep waste disposal for forever chemicals, etc. So I just show you different scales of storage of hydrogen on this slide, and now these are the different scales of power, or sorry, energy, not power. 10 gigawatt hours on the left, on your left, and on the far right, 10 megawatt hours. So we have 3 or 4 orders of magnitude here of energy storage facilities. And some of them are subsurface, some of them are on the surface. Our geoscientists and geoengineers now are encountering another dimension that I never really grew up with or was educated with. I had no idea that I would also have to become a knowledgeable social scientist dealing with social issues like working with groups that are strongly opposed or strongly in favor or strongly something about energy and everything. But this is, I've been referred to repeatedly as that well-known fracker, okay, that well-known fracker. So, yeah, in New Brunswick in particular. So my comment to the students that are coming into the geosciences is that it's a fabulous career, but you know, you've got to know your limits, know your science, don't try to be an expert in something that you're not. Be prepared to learn to communicate. With co-op and with the presentations and with the fourth-year projects that geoscientists do and geoengineers do, communication is getting to be a better and better skill now. Back when I went to university, you worked in the oil patch. In the summer, there was no such thing as communication except a few grunts now and then. And, but nowadays, you're expected to be able to stand up after 6-week work at Syncrude and give a 30-minute presentation on PowerPoint slides that everybody appreciates. It's a different world, quite different. Don't step out of the bounds of your professional knowledge, and be careful before you step into an advocacy position, because once you step into an advocacy position, you are painted with that advocacy position for the rest of your life, because remember, anything that you put on the internet never goes away. It never goes away. So you might, in a fit of unbridled passion, say, shit, I'm really upset at that, I got to write on Facebook. Well, 25 years later, oh, you want a job at our... I don't think so. you know, it's unfortunately that's the way it is. So you have to be very careful before you decide to become an advocate. I'm not saying don't become an advocate, but think it through. So we have many successful ones. One of my favorite students in geological engineering here at Waterloo was the smartest student I think that ever went through this department. And she is now the head of the Canadian Heavy Oil Association in Alberta, and quite a smart, I still say young lady, Carolyn. And that's it. I want to repeat, the oil and gas industry is not dead. It is evolving, it is moving into geothermal work, it's moving into subsurface energy storage, it's moving into hydrogen work, it's moving into other areas that are going to affect in the future your day-to-day existence and make it pleasant. So, thank you.
Okay, Simon Gortry. I'm doing the employer's perspective. I'm like trying to represent the final part of the education supply chain, hiring people coming out of school. So, let's see if I get this right. Down arrow. On the map. Okay, well, there we go. Oh, really? Got to point to the right. Okay. Button challenged. So what do we look for in an ideal candidate? Someone who can do useful work almost immediately. And for that, of us in consulting, that means chargeable. But it also, I'm sure it's the same equivalent of chargeable. Productive, straight away, is what we're looking for. We're looking for someone who's not going to be a drain on other staff. We're all overworked. We don't have time, really, for training people. We're looking for people who can step right into the role. You know, so we're looking for someone who also has the necessary skills and the certifications. I mean, I'm listing the ideal candidate here. We haven't had an ideal candidate in a while. Got things like first aid, driver's license. Please have a driver's license. It's very difficult in our field in particular. You're going to go out into the field most likely. You're going to need to drive a vehicle. Things like it's useful if you have things that like we have to train people on how to use an ATV, how to drive a UTV, boating license, things like that. Things that you have out there that show that you've got a certain amount of field work. You've got to understand and have the perspective that we're a business. We're not, on the consulting side, a charity. We do try to work, you know, for the good of society. We all took ethical oaths, I guess, when we become PGO. We're not out to rape the world or anything like that, but we are a business. Somewhere out there, somewhere, there's a shareholder or owner or something like that that's looking to make some money. We need someone who plays well with others. This is probably one of the most important skill sets that you can have, and probably one of the hardest ones to figure out. Each company has its own culture and plays its own game. So when play well with others, you've got to figure out what that company rules are and figure out how to fit in there. It's really useful if you bring new skills to the team. We usually have already trained the people with the skill sets that we have already and operating at, but one of the big advantages you have coming out of school is that you've been taught in the latest techniques. You have different skill sets. We also need people who have the fundamentals. There's no way we're in private industry going to train you in the fundamentals. You better have it. You're not going to be able to learn it from us. This doesn't mean to say you need to go back and be able to solve all those physics questions from Physics 101. It just means to know that you can look up what an equation means, you can apply an equation, and you can do the basic stuff. We need you to be flexible and handle uncertainty. That's kind of what it's like in the business world. There is not much predictability out there. We might hire you to do a job. It might be great. We're like, God, we've got a solid job. You're going to be working on it for 6 months straight. Then, before you know it, it's up. 6 months is up. That job's done. You've got to be ready to do the next job. And we need people who are patient and willing to learn. That's probably, you know, you might be very excited and very eager to take on new opportunities. But the opportunities that the company can present depend on what work we have coming into us. It might be that we don't have anything new and exciting. You might be stuck on a relatively boring job for a while. You've got to be prepared to stick it out. Maybe it's basic data analysis. Sometimes you get lucky. It's a matter of having the right mindset to be when the good opportunity comes along that you're the person who's there and ready to be there. But you've got to be a bit patient on how you get there. So I'm going to try and do this polling thing. So I just let it sit there. So I threw up what I thought was going to be important based on my experience, but I'm just one individual working away here. And I work in consulting, and I basically worked in consulting since I graduated from university. There are other skill sets which would be interesting to hear what you guys have to say about. Yeah, communication. See that? Communication is important. You can't really, it's a mandatory that you have communication skills. That might not be, but what communication means is a really varied thing. That might be communicating with your teammates. It might be communicating with traffic control. It might be communicating with a local First Nation. It might be dealing with the public a bit. It might be dealing with your boss. Wow, they're flying up here really fast. Technical writing's a good one. Math, physics, curious, hydrogeology, I see that. Quick learner, that's a good one. Yeah. All right, I'm going to move it on. Just go. Oh, look at that. Different perspective. Okay, so I got another question for you guys. Anyone here has probably hired new graduates. Do you see where they struggle? Because I can tell you, I've got my own, once again, I got my own experience where they struggle. Can't write. Who put a first year in charge of writing something? I mean, yeah, writing. Excel. Why did you hire a graduate who could not do Excel? One thing, if you are a student right now and you do not know how to use Excel, go to college. They have absolutely brilliant 3-month programs that will teach you all these basics. Run macros, stuff like that, figure out how to do a bit of Python. You've got to be able to crunch. Like, it's not a high billable rate task, but it is a great task to have on your first day. Critical thinking, that's a good one. There's no such thing as a bad question, we've heard. Well, there probably is lots of bad questions, but the ability to the other side of that, the ability to ask a good question is a very good ability. Attention to detail. Absolutely. The number, you'll probably experience this all, and anybody who's worked for a while, it's the first time you hand something in to your boss, they look at it for about 3 seconds, flip to page 3, and then throw it back at you. Attention to detail. Don't be a silo, that's definitely it. Reach out to people. It doesn't have to be your boss, it doesn't have to be your superior, your co-workers. You know, everybody wants to see you succeed in this position. They've invested a lot of time through the whole hiring process. Nobody wants to see you fail. Quaternary geology, my personal favorite. Was that you, John? No. All right. You guys are all seeing the same thing I'm seeing, right? Okay. Okay, so there are my anticipation look at what the top complaints are about graduates. Missing key skills. A lot of people come into the job thinking they've got it. They might come in, for instance, we're hiring somebody who's a modeler, and they don't actually have modeling background. You can look at these stats here, and you say, oh my, it's like, if you're a student here, you might be looking at it saying the number of the students' enrollment's going down, and the industry demand is high. I've got it made. I've got a job for sure. But you don't, actually. You've got to get through the culling process of the interview. And what we're looking for is somebody who can step into the job more or less straight away. This is, again, our ideal candidate. So you've got to have a skill set that what we're looking for. You know, it basically divide it into two or three positions. Modeling, whether that's groundwater model, free key, or that type of thing, but it also can be the presentation of data, the three-dimensional visualization, that type of stuff. That stuff is very, very handy. Back to communication and stuff like that. We data process a lot, but we do spend a lot of time trying to explain things to stakeholders, whether they be the public or the heads of mining companies, what they should do to make the right decision, or what we think is advise them on what the decisions are. And if we're not advising them to push them to one way or another, we're trying to show them the costs and benefits, the pros and cons of things. To that, you've got to be able to communicate. A poor mix of technical and social skills. We probably all know people like that. They're people who are too technical but can't communicate, and people that are too social and aren't technical enough. That's a tough one to define because it will vary from company to company. Some companies are made up of technical people that just sit in the back room and never talk to anyone. Other companies are made up of people that are out there and dealing with the public all the time. You'll figure that out when you enter the job market where you might fit in that spectrum. And when you find your happy place, you'll be happy there. Not aligned with the work hours. This is going to sound like an old person complaining about young person, but there is. And we do a lot of flexible stuff. You can work from home, you don't need to work regular hours, that type of thing. That's what they say. But if you don't work regular hours, and if you do choose to work from home, you will be disconnected from people in the office. You're not going to learn, you're going to learn at a rate of about 1/10 remote work, not showing up at core hours, to somebody who shows up and is there most of the time. So if you want to learn and you want to get ahead, and you don't have that much time to waste, I would say, because everyone's going to, the people who are there are advancing ahead of you, and you don't want to get left behind. You want to show up at the office. And then, too expensive for their contribution is more, perhaps, this is the corporate side of things. Companies always want people who will work at a lower cost than other people. So, particularly when you're a new graduate, you're not actually, sadly to say, adding that much value to the work straight away. That comes with a little bit of time. Geoscience is a complicated field. It takes a couple of years to get really, really good at something. And once you're good at it, you've got it made. But at the beginning, you've got to sort of remember a new graduate is a bit of a charity case. And you've got to remember that in your position and where you sit. And I was wondering if okay. Quick poll here, another poll here. Where have you had success generally out there integrating students, new graduates, into the work environment? Field work. We often throw people into the field. That's a good one. Why do we do that? Because first, the training requirements for field work can be delegated to a bright person with about 2 years' experience. And then you can become immediately useful. It's also hour-heavy time, way to get chargeable, that's for sure. So we do look for people who've got fieldwork experience, people you can throw immediately out there into the field. Compiling data, yep, that's another good one. Again, Excel, macros, that type of stuff, it's very useful. Lab testing, also a very labor-intensive task that you don't want to put highly experienced people on. Buddy programs are a great one. Generating figures, yep. Generally, again, the universities are good at teaching people how to use the software that the rest of us don't know how to use. Devoting time to mentorship. That one's going to make me pause, because if you think about it, how many senior people actually have time to mentorship? Right now, the demographics of the industry are changing. There's a whole bunch of people who in their 50s and 60s are either retiring or have retired. The demographic there definitely bows inwards. So in that sense, those people have got too many reports and too many things to do. They can't actually do too much mentorship. What you're going to do with mentorship, you've got to find people who are younger, down the chain type thing. It's not going to be the older individuals. You want to find people with a few more years experience than you, that you can connect to. Those are excellent mentors. So I throw up here a couple of solutions. We do want people who like the outdoors. I mean, not every job in geoscience is the outdoors. We just saw a whole bunch of things. If you're going into corporate finance or medical geology, well, maybe you don't need to go outside. But for most jobs, it's going to be outside. And it's kind of one of the subtle questions that might get asked in an interview. If you've got summer or co-op experience, that's excellent. Especially, those means you've integrated already into work environments a couple of times. You've gone into something, tried it out, succeeded, come out, gone into something else, tried it, come out, and succeeded. that is great experience. If you're at a university that helps you with that, that's great. I would say companies themselves, I mean, ideally, of course, the company wants the ideal candidate to walk in that doesn't need any training or anything like that. Well, on my side of things, they're going to have to bite the bullet and spend some time on training. You can ask that type of question in an interview if you have the luxury of choice. And companies are not run by new graduates. They're run by much older individuals, and some of them are run by professional business managers that never even went to geoscience school. So they're not going to remember what it's like to be a new graduate out there in the field, so keep that in mind. I mentioned this earlier, face-to-face contact's really important. You're going to do the best learning if you can get in front of somebody, even if you're just sitting there. The amount of information you get from sitting within the same office environment as someone with a couple of years more experience than you, you'll get to see what it's like, what the intensity of work's like, who they ask questions for. You can mirror your behavior off them. And technology. We had this problem where we can't get people to go up north on 2-week rotations. Now, there is actually a technology solution to this. We go up there and we send them up with a Starlink system. And that way they can stay in touch with loved ones, much easier than it ever used to be a sentence. You're going to jail for 3 weeks. Now you can go up there and you can FaceTime with the kids and stuff like that if you want to do that. So there are some technology solutions which are coming along which can make fieldwork more bearable. And then I threw up another question here. What are the barriers to companies investing in new graduates to make them more successful? I know what ours might be. I'll give it a few seconds if you've thought about it. It's all going to boil down to one thing really. Budget. Yeah. Time, money, yeah, training, all the same thing. Capacity, I like that one too. Finding capacity is a really important thing. Capitalism. Could be right. Greed. If you're at a company where your boss is just thinking about greed, maybe it's time to move on. I mean, it is a business, but you do want it to be a two-way street where you are getting some learning out of this. Management priorities. Yeah, that's a good one. It's tough to sort those out. All right. And I think that's it. We've eaten up almost the entire 2 hours. You got nothing? Oh my gosh, Manuel.
I'm going to make this quick, I promise. We're going to skip this next question, just for interest of time. So I'm just going to speak to a couple things about my perspective on the issue. I'm going to start with the first bucket, which is what I think are institutional constraints. And when I say institutional, I mean the higher ed sector. And then I'll talk a little bit about the students and their needs, and then some potential thoughts on solutions and moving forward. So the first thing that I want to talk about in terms of institutional constraints are the evolution of academic units, and some folks already mentioned this. There was a move away from having traditional earth science departments to merging with geography into environmental sciences and that sort of thing. There are some earth science departments left, of course, but that whole environmental science has really kind of it often comes together now, I guess. And what that means is there's always that sort of tension between the demand, the supply, and if you have these broader academic units, you have sort of competing clusters of types of faculty that are being hired. Hydrogeology is inherently an interdisciplinary topic. And yet we as universities are organized still along fairly traditional boundaries. And so sometimes it's difficult to have scientists that should work interdisciplinarily work together because of where they are in the institution itself. So again, there's just ways that budgets are organized, ways that faculty lines are established, and so on, that affect that kind of thing. And lastly, the economic pressures in higher education. We've had a lot of, it was mentioned already, there are some significant financial concerns in many of our universities. and it is the election coming up, so just, I'm not going to say much more there, but do vote, I guess. Okay, changing student context. I just want to make this quick, and then I can expand on anything if people are interested. But in my mind, there's also the changing context in terms of the student themselves. Like as a teacher, I've been at Guelph for over 20 years, and I see a very distinct change over those years in terms of the types of students that I interact with. So the first one is the COVID hangover. I know it's been 5 years, which is kind of odd to think about. It's sort of a big number now. But I think there's still very much a COVID hangover, and that's because a lot of the students that are now hitting university were in high school during COVID. And it has had a great impact on a couple things. One, the social aspect, believe it or not. A lot of people had a very hard time during COVID. We all did. But I think high school, I mean, I don't like to think about my high school days. I don't like to think of high school plus COVID. That just seems like really rough. So on the social side, but also the learning context. So we see students now in university that are panicked in in-person exams. They've never sat in a room with other people and had to perform on a test, which is like odd. We all sat there and we were just kind of stunned, you know, as teachers, because you're like, oh, I'm just dishing out this exam, no big deal. But it's a real thing. The second one is mental health. This is going to get better, right? By the way, the positive is going to go. The second one is the mental health crisis. So this has to do with world affairs. It has to do with the climate crisis, biodiversity crisis, the social end of things. Black Lives Matter wasn't that long ago, and it still is a thing, obviously. Things like also the economics of life in general. My 16-year-old already knows that he's never going to own a home. That's kind of weird. I don't know about you, but I don't think you should be worried about that at 16. So anyways, the odds, I guess your odds of succeeding as a young person look pretty low, and that takes a toll very much on their academic performance and their ability to perform in an academic setting, and their focus on their learning as well. This is a positive bit, I think. Many of the students now come to us with very much a multidisciplinary view of things. So they are not so much interested in a single discipline, but they tend to be really excited when you start talking about certain topics like issues or a challenge that we're facing where they see themselves as changing the world. Like if you think back when you were 20, I mean, we were all kind of the same, I guess, but at that age you kind of think, okay, well, I've got, you know, it's just sweat equity here. If we put our hands to this, we can maybe figure it out. And also the trend towards an applied approach. And the decline in MSc graduates is a complicated or probably multidimensional, there are multi-factors here, but I think one of them is that students are more and more interested in the applied approach, and they see research as just too niche, too esoteric. They just want to apply the knowledge and get some things done, get some things solved on the ground. So what this means is it has an impact on how we recruit people, how we organize ourselves in a university, and so on. What programs what do we call our courses? How do we organize the programs, things like that. Lastly, the changing student context is also AI. So obviously AI has had a big impact, is having a big impact on many sectors, and education is no different. We as teachers need to consider how we teach, how we assess. You really can't assign an essay anymore. There's really no point unless you want to just read a whole bunch of Copilot, ChatGPT generated content. It's just not as effective, right? So we got to go back to our principles of like, what are our learning outcomes? What are we trying to get the students to learn? And then do something different in terms of trying to get that knowledge across. So lastly here, some possible thoughts on solutions, meeting students where they're at. So there's been a bunch of talk about curriculum. I think here we need to think a little bit about our curriculum and see right now, for example, geoscience obviously requires first-year science. And we have many students that say, well, you know, I came to university to study environmental science or geoscience, and I spent my first year studying everything but that. And first-year physics is not really as exciting, or it could be made more exciting for geoscience students if it had very specific geoscience examples, for example. So that's one aspect. And then the other part is potentially including a lot more experiential learning and work-integrated learning. So co-op has been mentioned as a very good way for folks to be workplace ready. And there's a lot of people, including myself, who are exploring internships at the graduate level now. Even at the PhD level, there are some universities that are doing internships at the PhD level. And the idea here is that by connecting with industry, you kind of inform some of your fundamental research that you're doing, and you get to see what are some of the problems out there. And then those folks are more workplace ready when they get out, but also the research could be a lot more relevant and sort of focused on some of the issues at hand. Diversifies your credentials and pathways. So here what I mean by that is not just offering degrees, but thinking about long-term continuing education. So certificates, and Randy mentioned some of these already, course-based masters, graduate diplomas, micro-credentials, those sorts of things. Harnessing the skills and knowledge of the environmental scientist. So as a geologist who teaches in a primarily environmental scientist kind of program, they are super keen and they do have some skills. They're not as technically, there's fairly wide gaps in their fundamental geoscience knowledge, but they think differently and maybe in ways that will be very beneficial for some of the challenges we're facing today. So some of the skills that you folks thought were missing in our current graduates, sometimes the environmental scientist has that much better because they're just kind of used to, as generalists, they tend to be better at integrating things from different perspectives, using different data sets to solve different problems. So I think we need to kind of consider maybe how to bring those folks up to speed so that they can qualify for PGO, for example, once they're done their degrees, maybe through additional training, but harnessing that skill and knowledge. Integrating principles of EDI. This is really important from a number of perspectives. We need to do this in our universities, in our teaching, in recruitment practices, both recruiting at the university for the students that we recruit, but also in the workplace environments. How do we recruit our new employees? And then obviously the workplace culture, giving a sense of what your workplace is all about, and having that diversity is going to make it more welcoming and inclusive, and in turn is going to attract a more diverse set of employees. And lastly, just high school and elementary school outreach. I still think that's pretty important. It will spark the interest early on is one way to create that passion that drives people to those career-long commitments. So I'm going to end it there so we can have a wee bit of discussion. I don't know what time we were supposed to end, Steve, but I'm sure you're going to help us now.
Yeah. Okay. Okay, yeah, well, that was supposed to end half an hour ago. So I thought we were going to have a 1 hour, battle rock'em sock'em discussion here. So we still have 20 odd minutes, but we will do that. So at this point, I mean, we've heard, wide spectrum of topics on where we should go, where we could go, opportunities, and so on. So I think at this point, we'll just open it for questions right now. Maybe no one jumps up. I could maybe ask one to start. I mean, I was kind of curious why the PGO numbers are going up and the student registration, in universities is going down. It's like a total opposite graph, and I don't know if you guys have any perspective on that, maybe just to start us off. And I don't know who would want to answer that, if anyone, or maybe you have no idea. Dave, maybe? Or either of the Daves?
So anyway, I think part of it is when the transition into this geoscience world, when you become a professional, takes some time.
Okay,
so
so
we're
it's just a
probably
lag.
seeing a time lag.
Okay.
And that will probably change. But what I did see in that data set is it's pretty uniform. So you don't see that same type of drop and increase that we've seen in terms of enrollment. Anyway.
And what's also, it's been a function of prior to the outreach program, there really, PGO is largely driven by volunteers, so there really wasn't the resources available in the early days of the PGO to get out to every single university. Now that now that PGO is a senior organization, if you will, it's become mandatory that we get out to see every single university. I think there's 16 some odd universities in the province that offer a geoscience program, but that takes a lot of staff time and volunteer time to go to between Thunder Bay to Kingston and every institution across the board, and that takes planning. So that's been a big, and there's also a generational divide where students, there's universal acceptance. Oh yeah, we understand why we have to get registered. It's not that, how do I put this diplomatically? Young people get it. It's just a matter of, yeah, we have to have this. There's not the resistance, and we do see this, and this is just an observation, that people that may have graduated 40 plus years ago say, why do I need to get registered? That's an observation, not a comment. And the younger people seem to be more in tune with, yeah, this is part of social license. This is something that's seen as a point of pride. I got my designation. So long-winded answer to the question, but I think it's just a matter of we've been getting out there and people have been joining the ranks, and that's why we've seen the increase upward trend.
Thanks.
Yeah, I just wondered if you saw any impact from Walkerton, and then with that, do you have a sense of what, like, an issue today that people see and would scream sort of groundwater experience and relevance there?
So I think clearly almost everyone here that's after a certain age worked on source water protection to some degree. So Walkerton changed the landscape across Canada, North America, folks would say maybe internationally. And I think it did two things. It made people aware that groundwater is vulnerable and could lead to a serious health impact. And people change when there's a disaster. So that terrible situation caused people to really think about it. So we've restructured. There was a need for hydrogeologists. It ramped up in a practical way, to Emmanuel's point. People were looking for a practical way to solve a problem after that. I think it had a great, but somewhat temporary bump. Not that we need another disaster, but that's the type of thing that pushes the chess piece along. And of course, we're a different world because of it. Our whole curriculum changed as a result of it. We taught source water protection after that. We taught microbiology in our contaminant hydrogeology classes, which we really didn't do much about till then. So it was a real significant turning point.
And let me just jump in. I don't think we need another disaster to say we need more hydrogeologists. We need more hydrogeologists, that's for sure. The projects society, population's growing. The projects we are doing are larger. We're going deeper into the subsurface. We're building bigger tailings facilities, bigger mines. That groundwater is, there's groundwater regulation out there that needs to be considered. The need for hydrogeologists is high. We don't need to have a Walkerton or equivalent or Elmira or something like that. So
I should just say that if you have a question, if you want to ask to a particular panelist, maybe you could mention that too. And if not, that's okay too. But at the back, yeah.
Sure. Richard Murphy from GHD, so on the consulting side of things. What we see with a lot of young professionals coming into the business is we're seeing a lot of those earth science graduates come in to work in our hydrogeology field. and then they realize that they've got this huge hurdle to overcome to actually get licensing. So I guess a question, Dave, on the outreach side, is PGO's outreach focused on the earth science programs, or are you also dealing with the environmental science programs? Because from an employer standpoint, it seems that there's a lack of understanding of those young people when they're going through school, of what they're going to need to get their licensing.
So when an outreach program goes to, say, Waterloo, for example, it's a tailor-made program depending upon what courses and what curriculum are offered, whether it's just straight hydrogeology or geophysics or earth sciences. So it depends upon what degree is being offered, but that covers all three streams that are tied to the knowledge requirements. So there's not specifically one presentation for all schools. It's tailor-made for each individual one, because some may not offer what other programs do.
Are you asking, like, you're taking environmental scientists who then are learning that they need different requirements for the geoscientist? Is that what's happening?
We're hiring environmental scientists who really want to be a hydrogeologist
Yeah.
and want to get their license.
All right. I don't think the PGO goes to the environmental science things. We're talking amongst ourselves type thing.
But the other side of that is that the environmental science programs I showed you, the geoscience program particularly, is designed by people like John Johnson in front of you there to ensure that those students are eligible when they leave. They may not have the same breadth of courses, and they need a little bit more education in certain areas, but they're eligible coming out of those programs, if that's part of your question. And in reality, pardon me? No. Yeah. And one of the ways we try to distinguish the program from other environmental programs is that if you take these programs, you will be eligible for a professional designation, whereas other ones you will not be. So we try to, working with Dave here, try to be sure we're very clear on that. Right.
So with all first-year programs, with all undergraduate programs, now every single university in Ontario has their curriculum aligned with the knowledge requirements, and the knowledge requirements are the same across Canada. It doesn't matter what province or territory, licensing requirements are the same. So that's why these outreach programs are so necessary, to especially connect with students that are in first and second year to figure out what courses they want before they get to third year and fourth year, and then go, oh shit, I need, physics, or I need calculus, or whichever. So we try to do this outreach program and get people in touch as early as we can so that we can iron those out.
I can actually speak directly on this. I graduated from University of Western in 2015, so that was a while ago, from the environmental science program. I tangentially learned of the PGO through some of my friends in the geoscience. I didn't know what use it was, and now I work with Reg 153, and I'm facing maybe going back for first year physics. So yeah, I would say that's definitely important to point out, because I'd say a lot of people in my program were specifically interested in the remediation side, and a lot of that is Reg 153, so it's really useful to have your PGO for that. So making sure those people are definitely made aware, like, hey, this thing exists, and it's not just staring at rock all day.
Christine, maybe over. Oh.
Thank you. There are several professors on the panel, and we saw the numbers on the graphs that Dave Rudolph showed. And I think it's difficult for everyone to find good grad students. So, and you seem to be preoccupied by this and this grade, but do you feel that people in the higher hierarchy in your universities are also preoccupied by that, and are they taking concrete actions? And what will follow after your survey, or what will you do with that? Thank you.
Sure, I can go with that. At our university, definitely they're very concerned with falling enrollment in our departments and especially, and so that's part of why we're working on these new graduate programs. This is our dean's top priority right now, so that's definitely up there.
Maybe Emmanuel has a comment.
Yeah, I think I would say the same. The higher-ups, usually the Office of Graduate Studies, so the deans there, are very concerned about it. It is a national trend, so they are quick to say, like, it's not just us. But it is a concern because the master's students are often the engine of the research enterprise at a university, at least in the ones that I've been at. Some of the bigger universities probably have bigger PhD programs, but oftentimes you get a lot of the work done. You know, they're just smaller, sizable projects. There's values in both having PhD and masters, but oftentimes grad schools have more master's students than PhDs. So it is a real concern from that perspective. And certainly they've been, you know, we've been actively working on it, trying to diversify our offerings.
Okay, Don.
So this question probably goes to Emmanuel and Randy. Just curious, what kind of other programs internationally, have you guys been trying to look internationally at other applied master's programs that have been successful? This comes from a bias. I went to a program in Germany in the University of Tübingen that has a applied environmental geoscience program, and international, free tuition, not a plug, but it's a great program. And I got to learn a lot about the German, their view on environmental science, and it was their bachelor's program was a very rigorous, quantitative view of environmental science, not just like we're going out to a wetland to identify its health, but actually, incorporating math, looking at solving equations with programming scripts in their bachelor's. And then they had this follow-up program called the AEG, and to me it was a course-based master's with a 6-month thesis at the end, but just a very strong program and kind of changed my view of environmental science in general and where geoscientists fit in there. So I was kind of curious, what other programs have you guys looked at internationally, and any takeaways from that?
Sure. Yeah, so when I was working at the University of Kansas, this was something that we started developing there, and so I worked on a environmental geology master's program. It's professional science master's, so I'm fairly familiar with that program. Dave mentioned High4A at University of Arizona. They're working on a fairly small program, but they're working on this same sort of idea. I think we're a little familiar here with Tübingen. There's been some historical connections there as well. So we've definitely been looking around the world to see what's going on, and a lot of people are moving in this direction, I think.
Sounds like you should take over the environmental sciences. That's the push.
One of the things we see is in the course-based masters, there's a move towards including more internships as a capstone experience, or a sort of case-based study, problem-solving, like problem-based learning, basically, but at the graduate level. So having like an industrial advisory board feed you some situations, problems, sets that the students can then, more like a multidisciplinary team of students can then tackle. And yeah, I've seen this in a bunch of places, and I think it's much more embedded in Europe than it is here, to be honest. Yeah, but I think it can be very helpful for both the student and the company to try them out, to try out the student, and the student gets to, step into the workplace for 4 months and see what it's like.
I'll just add to that. In consulting too, there is a lot of consulting is like a lot of paperwork, maybe doing excess soils, following regulations, stuff like that. But at some point, you try and have to solve real problems, and you need equations to be able to do that. You can't do it through environment, like a soft arts leaning environmental science program. You need those people in the table and that type of thing. But to solve real problems, you need real science.
Thank you very much. I guess I'm hearing, we're asking the question, maybe why are we not getting as many kids coming into the Geoscience program? But I'm also wondering if we've maybe asked, why are so many of these high school kids going into maybe other programs like arts or history, and why are those programs so big? Is there something we can learn from those programs on what it is that's drawing those kids in that maybe we can duplicate over here in the Geoscience?
I think it would be great if we could change high school curriculum to include a geoscience course in it. That would be a good first step. We're at a disadvantage, I think, very often. There's only a few high schools that offer that.
More TikTok videos, probably.
And I think the key thing is to get to them a little bit earlier. You know, we were starting to hit, go and talk to grade 12 classes. That's a little bit late. They've already made some decisions. So getting in at the grade 10 level, it may be earlier. Getting in somewhere in late elementary with presentations would be a good idea. I think they're not aware of it. They see it on TV all the time, but they don't quite understand how a geoscientist fits into that. So it's a really great suggestion.
I have a maybe controversial point. I heard recently that most, people at high school age are spending an average of 7 hours a day on their phones. I don't know how you can get through an engineering or science degree if you're spending that much time on social media. It depends what they're doing, but it might be, I'm being controversial. It might be they're going into history because that's a program that's maybe easier. They still get the university experience, but they're not got the mental rigor or toughness to do it. Or at that stage. I'm sure they can figure it out. Somebody's waving their hand way at the back.
Yeah, no, Don's got someone here first, okay?
Thank you. Further to the question about interesting high school students, is there room to develop more internship programs for high school students, maybe month or 2 months, paid maybe, in cooperation with either industry partners or conservation authorities, so that these could be offered in more locations throughout Ontario, not just people who are conveniently within driving distance to a university? And could this help boost interest amongst the high school students?
Just before the response, I know from my own kids' high school, they do it for the trades. They have internships in the high school and they go out, work for mechanics, work for whoever, and because I've seen the presentations and the awards they got at the end of the year. But I've never seen anything for geoscience.
Anyone on the panel comment?
There are health and safety, legal, and administrative barriers to that. I don't know whether it's possible to overcome those barriers and reach out for like 6-week, 10-week internships for 14, 15-year-olds. I'm not sure that that is actually feasible with our current structure. Can it be changed? I'm old enough to be a little bit cynical about that one. When your lawyer says to you, you have to change your playground because this playground might eventually injure someone, well, they say the same things to us. What are you going to do with 14-year-olds in your laboratory, on your field trips, in vehicles?
Oh my God.
It makes it very complicated.
Before that question, maybe Dave, I mean, this ties into what you mentioned about a camp, like a 1-week camp at the university or something. I mean, that sounded interesting to me. I've never heard anything like that, but it sounded maybe tied.
Karina, could you mention that? Just explain it just briefly.
Sure.
Thank you.
So for those of you who don't know, my name is Karina McDonald and I run the Earth Sciences Museum here on campus. This summer we're going to be starting a grade 11, 12 camp for high school students. I'm largely involved with that. If you want to help, please connect with me. Or if you have stuff to give students, please connect with me because I'm looking for that. We're still creating the program and reaching out to faculty to help kind of create what we're going to introduce to them. But we do have the goal of introducing them to, of course, geology, hydro, geophysics, and water science. But one of the things I did want to mention, I think, Peter, you were asking about internships. High schools have co-op programs, and they they're always looking for people to take co-op students from high schools. And in fact, I have one right now. They're a great help when you need extra things done around the office. So that's one way to introduce them to this field. The other thought, and one thing that I've run into over the years, is that we have so many terms for geoscience, earth science, environmental science, and we confuse the youth. They have no idea what we are, to say it bluntly. So I think terminology is a huge one. And then, of course, getting to them. And yeah, you're right, Randy. Our school systems do a terrible job of introducing geoscience to them. Anyway, I don't really have a question. I just wanted to comment, so sorry.
Any comments on any of that from the panel? Okay, maybe we're getting close to our time, but maybe one or two more questions and we'll close it off. We got a 10th year anniversary cake to eat somewhere, I think.
Hi, everyone. If you'll indulge me for just a moment, I wanted to state about my personal experience that it is possible to get a high school co-op program in the sciences, even in light of a high-stress health and safety environment. When I was going through my high school experience, I was debating between getting an English degree and a science degree. And the deciding factor for me was that I participated in the Deep River Science Academy, which was based out of Chalk River Laboratories, which is a nuclear facility. And I did an 8-week high school co-op to earn credits for my diploma in a chemistry lab where I had to take radiation safety courses, and I was supervised by a master's degree student, and it was a fantastic experience. So I just wanted to say it's very possible, and it's a great way to get young people aware of what their options are before they're at that decision phase of what university do I want to go to, what program do I want to apply to. And I thought it was a fantastic program. Unfortunately, the Deep River Science Academy no longer exists due to a lack of funding, but absolutely wonderful. I was there as a high school student. I went back and tutored as a university student. I think that there's a tremendous value in that kind of program.
One more.
Thanks. I'm just curious, how many people here have volunteered at a children's groundwater festival? That's amazing. This is an initiative that's 30 years old. We've educated over 1 million kids. This is how we can very actively get involved in young people's lives. And a word of caution as we look at this and move forward. Dave, you said how Walkerton changed people's lives. The inquiry that came after caused the college, primarily Fleming, that did the training for well drillers, to create a 2-week course. And I've been teaching geology and hydrogeology in that course. But as time has gone on, people forget about it. Now, the Ministry of Environment has gone to Fleming and saying, you don't need to do that. You just need a 30-hour online course. So our drillers are getting no practical experience. They're taking a course online for 30 hours and writing a test. So people forget. And of course, we don't need another Walkerton. But we play a key role in getting that message out in our everyday lives of the importance of geoscience. I know the comment before about so many titles about scientists and stuff, right? Like, I don't want us to wave too far away from the core base of what a geoscience should do. Our young people have very little geology training. You know, they don't even know what a depositional system is because of environmental science. You know, we have to remember what our core is. So the drillers, I think, are starting to lose that. And as we continue to develop courses and stuff, I don't want us to get too far away from what a geoscientist really needs to know.
I can just add a few words about the Walkerton tragedy. We had an anniversary not long ago, and we had some talks at the University of Guelph for the Morwick G360 Groundwater Research Institute. And it was fascinating on all kinds of levels, but I remember we had a guest from Walkerton who spoke about it, and that was his message. We cannot forget, and it's very easy to forget. And I was reminded this year because I talked about Walkerton in my class, and they weren't around. Like, they weren't born when it happened, right? Like, so it's very easy to forget, and I'm not advocating for another one, absolutely, but I think it's going to become different. I think the message is going to come from different sources. Like, we're having different, different problems, I guess. The flooding, the climate change is going to bring new challenges, and I think geoscientists will have a place to help in that context.
Okay, so maybe we'll close it off there, but in closing, there's a couple, are the slides? No, they're not there. I had a couple slides on, oh, is it up there now? Yeah, so one of the things that in looking at this geoscience education, I mean, I don't think many people have heard of the Canadian Federation of Earth Sciences. It's a group that we all belong to if you're a member of IH or CGS or whatever, and they have, within that federation, it speaks for Canadian geoscientists internationally, and they do, struggle with the same volunteers and trying to do things that help all of us. But they have a geoscience education network that was created a number of years ago. So there's nuggets of initiatives, I guess, across the country that, we don't have to start from scratch. I just wanted to make people aware of that. Some great documents if you want to talk to young people about geosciences. There's some great materials out there. The PGO right now is offering, so this fellow, I mean, Simon mentioned him in our discussion, this fellow from Britain, Hayden Mort, who talks, he has a website called Geologize, and it's communicating with geoscientists. The course is free if you're a PGO member. You just got to get the code from them. But what he talks about is that as geoscientists, we preach to the really low-hanging fruit. He has a picture of an apple tree, and he says, all our geoscientists, we talk to the fruit on the ground. No one goes up high to try and recruit kids into geosciences. We talk to people who love the outdoors, who are into rocks, who are like ourselves. We have tons of passion, but we don't spread in the right way. And so I've looked at a couple of his videos, and they're really interesting, and I think that everyone really should have a look. And if you're a PGO member, it's a 10-hour course. It seems like a great, I haven't done it yet, but I just signed up. I'm going to do it. So again, all of us are ambassadors for geosciences, and echo some of the comments that it's up to all of us. And so thanks so much for our panelists today. I hope you enjoyed the discussion. I think we do have a 10th year anniversary cake somewhere out there. So let's have our last break, and we'll meet back after the break. Thanks so much.